All right. Hey, everyone. Today we're going to learn about law of sines and law of cosines. So go ahead and for this one, and we haven't taken notes in our notebook in quite a while, but go ahead and dust that off and find an empty page of notebook space. And we'll go ahead and get started. Okay. So first thing we're going to do for law of sines and law of cosines is we're going to talk about law of sines. So this is 4.7, or it's 4.7 in the textbook we haven't really been using. I don't think it's 4.7 in the College Boards thing, but we're going to call it 4.7 just for funsies. Law of sines and cosines. All right. So like I said, we're going to start with the law of sines. And the law of sines is not just for right triangles. So typically sine, cosine, tangent, those are all things we're used to seeing either associated with right triangles or associated with graphs of sine, cosine, and tangent. But today we're going to look at it as something that still applies to triangles, but not just to right triangles, to any triangle. So first we need a triangle. I'm going to make this triangle A, B, C with capital letters on the angles. And then the letter that's, or the side that's across from the corresponding letters, going to be like lowercase a across from A, lowercase b across from B, and lowercase c across from C. And you'll see why that's important in a moment. All right. So the law of sines says that the ratio of the sine of an angle to the length of the side is equal across all three sides and angles. So sine of A over A is the same as sine of B over the length of side B, which is equal to the sine of angle C over the length of side C. And you can also flip this. It doesn't matter really which way you do it. All of these ratios are invertible. Or able to be still hold using the reciprocal. So you can do B over sine of B and C over sine of C. Sometimes one will be, a little bit more easy to use than the other one. It doesn't really matter though, because they all work the same way. Okay, so when would you want to use this? So if you have the two angles and one side, or in this order, AAS, that should take us back to our geometry days, or angle, side, angle, if you have these two angles and the side in between, or something like that. Those are all cases that you would want to use the law of sines, where it's going to be most useful. It's going to help you find missing sides and stuff like that. These are the main two cases that you will use this for. The other one would be when you have two sides and one angle in this order, where you have like two sides and then the angle following it. But this is considered the ambiguous case. So we're not going to focus on that one as much today. We'll come back to this later. And we'll talk about like why it's called the ambiguous case and all that good stuff another time. So not today. We're just going to dive into law of sines, the way it can be used with these two different types of triangles that you're going to see. So let's do an example of using the law of sines. All right. So we're going to have a triangle. And we're going to know some of the information about that triangle. We know that this is 35 degrees. We know this is 103 degrees. We know this side is 20 And that is all that we know. All right. Well, what you would typically be asked to do is to find the missing sides and the missing angles in the triangle. So the first thing I would do is label what's missing. We know we are missing side A and side C. Great. We also are missing angle C, but this angle is going to be a little bit easier to find than anything else we're going to do here, because the angles on a triangle, if you remember back to geometry, add up to 180 degrees. So we can just take 180 and subtract off 103 and 35. And when we do that, we should get 42. So our first piece of information that we know is measure of angle C is 42 degrees. The other two things we are looking for are A and C. So we're just going to kind of collect those there. Okay. So the law of sines, when can you use it and how do you use it and all that good stuff? When you've got a pair of a side and an angle pair, it works really well. So what do I mean by that? We have an angle and a side that goes with it that's across from it. That's what we're looking for, because now I can do sine of angle B over B and put that equal to sine of angle A over A and stuff like that, and only be missing one piece of information. So that's what we're going to do. We're going to go sine of 103 over 20. And that's going to be equal to, let's do sine of A over A. But sine of A is going to be sine of 35, since angle A is 35 degrees, over A. All right. So when you're solving something like this, just a reminder that all you have to do is cross multiply. We get A sine of 103 equals 20 sine of 35. And then, of course, we divide by sine of 103 on both sides. So we get A by itself. And then this is what we type into our calculator. And one thing you want to keep in mind, I know this is AP pre-calc, so we've been used to having our calculator in radian mode for a long time. So if you go up to mode, these triangles are in have their angles in degrees. So we're going to go ahead and hit degree and change the mode back to degree mode for this particular unit. So then we're going to type in 20 sine of 35 divided by sine of 103. And we get 11.773. We're going to go ahead and round that to 3 decimal places. And we're good to go there. So now we know one more answer. A is 11.773. All right. And then you just basically follow the same exact process to find C. So we set up the same kind of thing, except with 42 degrees and C. So go ahead and pause the video real quick and try finding side C on your own, and then come back and check it. All right. Hopefully you took a second and paused the video and found the length of side C. We're going to go ahead and show how you would find that. So we're going to set up exactly the same kind of thing that we had going here. We're just going to go same thing exactly over here, sine of 103 over 20. And then it's going to equal, instead of 35 here, we're going to have sine of 42 because angle C was 42 degrees. Divided by C. We solve it the exact same way. We cross multiply. We get C times sine of 103 equals 20 sine of 42. We divide by sine of 103 on both sides. And we stick it into the calculator. 20 sine of 42 divided by sine of 103, we should get 13.735 if you round to 3 decimal places. So there's our final answer that we were looking for, 13.735. And if you're ever trying to check and see if things make sense, a helpful thing that you can remember from geometry is that the longest side is always across from the largest angle. So if we look at our picture and we go, okay, B is 103 degrees, that's the largest angle, and this 20 is the largest side because the other two are smaller than 20, right? And then the medium angle is 42 degrees, it's bigger than 35. And C, that means that C should be bigger than A. And it is. C is 13 point something and A is 11 point something. So that's a good indicator that we probably got the right answer, or at least an answer that's reasonable, right? We're going to be checking, is our answer possible? Is it reasonable? Okay. So that's how you use law of sines to find missing sides and missing angles, although the missing angle is easier to find. Okay. For the next one, oh yeah, we'll do that real quick. We'll do another example of this kind of thing, but we're going to see, this was the angle side case. We're going to look at also what it would look like to have the angle side angle case. It's not all that much different, but it looks a little bit different. So we'll give it a go and see how we can recognize that case. All right. So for example 2. Here we go. We'll say that this is 50 degrees. This is 58 degrees. This is A, B, C. This is 446 for the side length. And we're going to solve for all the missing information. So the first thing that we want to notice is that we have the angle side angle case, which tells us that we're going to use the law of sines. So that's step 1. Step 2, solve for the missing angle. Angle C, you got to go 180 minus 58 minus 50, which is 72. So we know this is 72 degrees. Great. Now we notice that this is our angle side pair. So everything that I set up for this, we're going to be using sine of 72 over 446 equals something. The two sides that we're missing would be B and A. So those are the two that we're going to be solving for. So when I go to set this up, when I set up this direction, we're going to be going sine of 58 over A. And then this one is solved the exact same way as the last one. Once we get down to this part, right? We've got this going, and then we'll set up another equation that's going to have the same thing for this pair. So go ahead and pause the video here and give this one a try. When you come back, I'll show how we solved for both side A and for side B. Okay, hopefully you did that and paused the video and gave it a try. Let's check our answer and see if we got it right. So for this one, step 1 is to cross multiply. A sine of 72 equals 446 sine of 58. All right, then dividing by sine of 72 on both sides, we get, let's see, 446 sine of 58 divided by sine of 72. We should get 397.694 if you round to the nearest tenth. So that's one of the pieces of information that we were missing. The setup for the other piece of information that we need is going to go very similarly. We're still going to use this complete ratio here. Sine of 72 over 446 equals, but instead of 58 this time, we're going to use 50 since we're looking for B. Sine of 50 over B. So we do the same thing where we cross multiply. B sine of 72 equals 446 sine of 50, dividing by sine of 72. So this time, 446, sine of 50 divided by sine of 72. We get 359.238. So that would be our last missing piece of the puzzle there. All right. So now we've done both types of law of sines, but really it's the same type. It's just recognizing the scenario that it can be used. Okay. That was law of sines. The last thing we're going to do today is the law of cosines. And as you might imagine, law of cosines is going to be used in different cases than you would use law of sines. So the same thing, though, we're going to set up the triangles. We get a picture of what we're looking at here. This is angle A, angle B, angle C, side A, side B, side C. And there's three formats for the law of cosines you're going to see. They're all the same, essentially. So if you remember one of them, you can remember all of the others. C squared equals A squared plus B squared minus 2AB cosine of angle C. All right. So first off, when we're looking at C, A, and B here, and even here, those are all the side lengths that we're talking about. The only place that we use an angle is right here with cosine. So if you can remember this, and it kind of looks like the Pythagorean theorem, doesn't it? A squared plus B squared equals C squared. Just a little bit different because, again, this is not a right triangle. Or it's probably not a right triangle. And then the other formats of this, A squared equals B squared plus C squared minus 2BC cosine of A. We kind of see the pattern, right? Whatever is over here, that's the angle that goes inside. Whatever's over here, that's the angle that goes inside. The other two, it doesn't matter what order B and C go in here as long as you have them both. It doesn't matter what order you multiply in as long as you have them both. The last way you could format this, B squared equals A squared plus C squared minus 2AC cosine of B. Okay. So again, if you remember at least one of these, we're in good shape. You want to use this if you have, it's the SAS or the SSS case. So if you know all of the sides, or if you only know one angle and you know two sides that are on either side of that angle. So we're going to see what that might look like for us here. So example number 3, this is our last example for the day. Here we go. We've got A, B, C. Let's see, we are told that this side is 8, this side is 5, and this angle is 65 degrees. And we're going to find all the other missing information. So first off, we notice that we do have the SAS case of things, right? Because we don't know all three sides. We know this angle, and we know the sides on either side of it. All right, so that's step 1, figuring that out. Then we notice that we need side C and angle A and angle B. So I'm going to start with solving for side C. And I notice also that we know, oops, that's B and A. So we know B, we know A, we know angle C. So that tells me that I need to use the one where side C is the only thing that would be missing. I don't want to use angle A or angle B because we don't know side C yet. And we also don't know angle A and B. So that would be a little bit of an issue. We've got two things that are missing. So I'm going to start with solving for side C. We know C squared is A squared plus B squared minus 2AB cosine of C. All right, so I'm going to input what I do know. I know A is 5, so we've got 5 squared there. I know B is 8, so we've got 8 squared there. 2 times 5 times 8, cosine of 65, since that's what C was. All right. Well, and then to figure out what side C is, all we have to do at this point is take the square root of both sides. So I can type this entire thing into the calculator. So grab the calculator, and we go, just don't want to cover it up, square root of 5 squared plus 8 squared minus 2 times 5 times 8, cosine of 65, enter. And we get that C is 7.429. Cool. We've got one of our pieces of missing information, and we can use that missing piece of information to solve for the remaining angles. Doesn't matter which one you solve for next, angle A or angle B. I'm going to start with angle A. So to solve for angle A, I'm going to need to use the formula that has angle A in it, which means I'm going to start with A squared equals B squared plus C squared minus 2BC cosine of A. Okay, so I know A is 5, so 5 squared. I know B is 8, so 8 squared. And then I know C is 7.429 now. So we want to square that. Minus 2 times 8 times 7.429 cosine of A, because that's the thing that we don't know that we're looking for. Okay. So next thing we want to do, I want to subtract from both sides. 8 squared, get rid of that, and 7.429 squared. Get rid of that. And I'm going to go ahead and do that in my calculator. So 5 squared minus 8 squared minus 7.429 squared. We get negative 94.190041. I can also multiply these three things really quick so that I get just one number. 2 times 8 times 7.429 is, we have negative since it's minus 118.864 cosine of A. Okay. Now we're almost there. I need to get the cosine of A by itself. So I need to divide on both sides by negative 118.864. So we're going to divide the negative 94 with all the decimals. And we get a big long thing, 0.7924, whole bunch of stuff, equals cosine of A. All right. So now we need to undo cosine, basically, right? So I need to do cosine inverse on both sides. Cosine inverse undoes the cosine. Cosine inverse. This is going to give us our angle that we're missing. So in the calculator, cosine, and then I'm just going to grab that answer from before, hit enter, so that puts the whole thing in there for me. And for my answer rounded to 3 decimal places, we're going to go with 37.588. All right, so now we know measure of angle A, 37.588. Luckily, we don't have to do that again to solve for angle B, because now we know 2 angles, right? We know that this is now 37.588 degrees, and we can subtract from 180 to find our remaining angle. We just go 180 minus 65 minus 37.588. We're good to go. Okay, so that's law of sines and law of cosines. I know that was a lot of things all at once. We're going to keep on this topic for a while, though. So your assignment is this worksheet. So the first page of the worksheet is not the assignment itself. It's just a reminder of law of sines and law of cosines, and the cases that you might want to use them. The second page, though, so the back of that is where it begins. Read the directions. You don't actually have to solve anything for the first couple. It just says determine whether the law of cosines or the law of sines is the best choice. So you're looking for that angle, side, angle, or angle, angle, side to use law of sines. And then side, angle, side, and side, side, side to use law of cosines. And then side, side, angle would also be law of sines. And then it says to actually put values into the formula, but you do not have to solve it. So say law of sines or law of cosines, and then substitute values into them, but you don't have to solve. That's that first whole page. And all the way through number 10, actually. Then, starting in this part, that's where you use the law of sines, law of cosines to find what's missing. So these ones you actually have to solve. So that's 11, 12, 13, 14. And then on the back side, 15 and 16. For the challenge problems, I'm going to say you don't have to do the challenge problems, but if you would like to give them a go, if you're bored, give them a try. Why not, right? More math, more fun. All right. So anyways, I know it's been a little bit, so sorry about that. A little bit of a long video, but I'll see you all on Monday, or not Monday. I won't see you Monday. Monday is Memorial Day. So just kidding. See you on Tuesday. Have a good one, guys.